I am waiting extra because whenever I get to going thrice, all of a sudden 5 hands go up. Going twice. He slowly took a sip of his tasty hot beverage. Coffee with a very little bit of sugar and a little bit more than you would think is a normal amount of cream. Going thrice. Oh! All right. One of my grade 10s had a new record today. I did going once, going twice, going thrice 4 times for the 4 different steps. And on the 7th time, I showed them the example. I don't get it. Where are you lost? Everywhere. But what about the previous 29 going once, twice, thrices? Yeah, nothing. Okay. This one is x minus 5 over x minus 3, x plus 1. And x cannot equal -1 or 3. Is everybody good? Going once. He scratched his nose hesitantly. Going twice. He reached for his tasty hot beverage and had another sip. He sighed contentedly as he placed his hot beverage back on his desk. Going thrice. And once again, he did not see a forest of hands be raised, so he was very happy that he must have taught his students how to do it correctly. Ah, there it is. Sure, Zorro. 2 over x plus 1 minus x minus 1 over x minus 1. No, I lie. X plus 1, x minus 3. Now I have to add those two. The common denominator is x plus 1 and x minus 3. Does this guy have the whole denominator? No. What part is he missing? So that means this would need to multiply by x minus 3, wouldn't it? If I multiply the denominator by x minus 3, what must I multiply the numerator by? X minus 3. What is 2 times x? 2x. What is 2 times 3? -6. Minus x minus 1. What is 2x minus 1x? 1x. What is 6 minus -1? -5 over x plus 1, x minus 3. Any canceling? No. So I'm done. Oui? Si? Très bon? Whatever very good is in Portuguese, because that's what Zara's working on right now. What is very good in Portuguese? What? Muito bom? Muito bom? All right. What is very good in Japanese? This? That's hard to write. Yame!
Yame, that means no.
Doesn't that mean thank you?
No.
That means stop.
Yes.
Yeah. We say that a lot in karate when we're doing something. Yame! All right. Number 3 in karate. Number 3 is 12x minus 1 over 2x plus 1, x plus 3, x minus 3, and x cannot equal plus or minus 3 and -1/2. Don't be shy. You can put your hand up when I say going once. You don't have to wait for the 3rd time. Yay! All right. I'll change colors though. 4x over. Factor that. I need factors of -6 that add to -5. What are they?
2x plus 1 and x minus 1.
Yeah, but let's actually do it. What are the factors of -6 that add to -5? Positive 6, negative 6 plus 1, right? So x plus 1, x minus 6. But it's not really plus 1 because there's a 2. So it's 2x plus 1 and x minus 3. 2x plus 1 and x minus 3. Minus 1 minus 2x. Nothing to factor up there. And here is 3 minus x and 3 plus x. Yes? All right. Now, looking at this, what do you see there und there? Are they similar?
Yeah.
They are, aren't they? So, since they look similar, would I have been allowed to do this? From here, could I make that negative x squared minus 9?
Yeah.
I factored out the negative, right? So couldn't I write here negative x plus 3, x minus 3? So it looks normal. All right, good. So now, what is my common denominator? 2x plus 1. Yeah?
Yeah.
Right? And x plus 3 and x minus 3. Now, when I bring that negative out here, what do you see right there?
2 negatives. So you can do
Subtracting a negative, yes? Which becomes
positive.
adding up here. And what do I have? I have this plus this, except it's not 4x and 1 minus 2x. I need to change them because I changed my denominators, didn't I? What did I add to this side?
X plus 3.
I needed an x plus 3. What did I need here?
2x plus 1.
2x plus 1. Multiply this out. 4x squared plus 12x, right? Multiply this out. What do you get?
Negative 4x squared.
Negative 4x squared
And positive 1. Plus 1.
plus 1. Right? Now, what do you see there?
It's no.
They're like terms, so I can collect them. 4 plus negative 4 is what?
0.
Gone. Any other like terms? No. 12x plus 1. Oh, this should have been minus 1, shouldn't it have? Yeah, that should have been minus 1. Right? Yeah, because 1 times 2x. 1 times 2x is
No,
2x.
it's plus 1.
It is plus 1.
Yeah.
12x plus 1. So that should have been plus 1. Over what?
Over 2x plus 1.
This
Yeah, that one.
whole thing. Yeah? Yeah. And again, always check. It's easy to make a mistake. Yeah, I forgot a negative right there. I can see where I made my error. And this one is, I have 14x over 2x minus 1, x minus 4, and x cannot equal plus or minus 1/2, and negative 8, and 4. Do I need to go over it? Yes or no? Going once? Yes? All right. Factor up there first. That is, I need to multiply to negative 12 and add to negative 4. What is it? Plus 2 over 4 and x minus 6 over 4. Simplify that. 1/2. 6 over 4 is 3/2. So it is 2x plus 1 and 2x minus 3. So I've got, change colors, 2x plus 1, 2x minus 3 over 2x plus 1, 2x minus 1, minus, this one is 8 and 12, right? X plus 8, x minus 12 over, this one is x plus 8 and x minus 4. Check for your restrictions. Got them right here. Start canceling. Where can I cancel? Where can I cancel? He waited patiently.
X plus 1, 8, and...
X plus 8, x plus 8. Where else?
And x, 2x.
2x plus 1, 2x plus 1. Leaving me with what? 2x minus 3 over 2x minus 1 minus x minus 12 over x minus 4. What is my common denominator?
2x minus 1 and x minus 4.
2x minus 1, x minus 4. What does this guy need?
X minus 4.
X minus 4. 2x squared minus 8x minus 3x minus 11x plus 12 minus, what does this guy need?
2x minus 1.
2x minus 1. 2x squared, 2x squared minus x minus 24x minus 25x plus 12. Now what do I need to do with that whole numerator?
Solve it.
Solve it. 2x, well, not solve. 2x minus 2x, what happens? Disappears. Negative 11 minus 25. 14x. 12 minus 12. Gone. Over 2x minus 1, x minus 4. Yeah? Yeah. Each question is worth what? What should they be worth? 10 each? You want a 40-mark assignment here?
10 each. No, not 10, 2.
What did you have to do to solve these? What knowledge did you have to bring to the party?
Factor.
You had to factor, right? So you should get
1.
How many points for factoring? There were more than one kind of factoring there, yes? Mm-hmm. So I should give 2 points for factoring?
Yeah.
Okay. Then what did you have to bring to the party?
The restriction.
The restrictions. How hard is it to check restrictions?
Not really. So
Pretty
1.
easy. So 1. All right. So each question now is worth 3. What else did you have to bring to the party? Common denominators, right? But common denominators are what part of math? When did you learn common denominators?
Like, it's a lot of...
Yeah, a long time ago. So we're only going to add 1 for common denominators. That's 4. But then you had to multiply all those common denominators, didn't you?
Yeah.
That's 5. I will offer 5 marks per question. You decide what you should get. Surprise, surprise. Everyone got 20 out of 20. Amazing. Then I'll give you a quiz on it on Monday, and everyone will get 2.
On Monday?
No, of course I won't give you a quiz on Monday, but I'll give you, the next quiz I give you will not be 100% for everyone like this assignment is. Amazingly. How can that be? I don't know. He said sarcastically. I'll get your mark from you Monday. Please turn to page 136. Now, this year we reviewed radicals, yes? Square roots and such. Then we used radicals to solve equations, didn't we? Well, this unit, we reviewed rational expressions, right? Well, now we're going to use those rational expressions to solve equations, to actually give us an answer. We will learn what x is, not the expression that represents it. Is everybody good? Okay, so an equation, you guys know it as something equals something, right? But in reality, what an equation is some expression equaling another expression. So, not writing here, I'll put a few examples over here. X plus 7 equals 12. That's an equation, because x plus 7 is an expression, and 12 is also an expression. Because 12, 1, 2, isn't 12 things, is it? That is how we express 10, 12, right? X plus 7 equals x plus 9. Expression equals expression. Anytime you have an equal sign, you can always find what x equals. X equals an answer. Is everybody cool? Our job in an equation is to find the unknown. Is there only one unknown all the time? No, there can be many unknowns, yes? Find the unknown values. And I'm putting the S in brackets because sometimes there's one, sometimes there's more. How do I do that? I isolate whatever variable I am seeking. Now, just to remind you, x plus 3 equals x equals 2x minus 4. How would you tell me what x is? How would you tell me what x is? You would simplify by doing what? Guys, this is a grade 6 equation. Somebody can solve this. Isolate x. Thank you. You move that over there, and it becomes x. You move that over there, and it becomes plus 4. 7 equals x. Right? Excellent. Well done. Good job. It is the same thing no matter what. We have learned to do this when I had square root of x plus 7 equals 4. We learned how to solve that, right? Same thing. We isolate x. That's what we're going to do now. But just like here, even though the principles are the same, the actual execution is difficult. Yes? All right. So let us have a look at this. As always, you know how to do this. If I asked you and I said, I'll give you $100 if you can explain how to do this, you know the steps. You could do it. Right? So let's write down the steps and then let's apply them. A rational equation, if a regular equation is expression equals expression, a rational equation must be a rational, and that's the abbreviation for rational. A rational expression equals a rational expression. Now, so far this year, we have been dealing with how many rational expressions at one time? Usually 1, right? Maybe 2. On that last quiz, I gave you 3, right? But did any of them have an equal sign? No. So the only difference now is you're going to have a question like we did yesterday and another question like we did yesterday, and now they're going to be equal to each other. So yesterday, what were the steps you followed to deal with just a rational expression? What's the first thing we did?
Factor.
Simplified by factoring, right? So what do you think our first step here is going to be?
Make it simpler.
Right. 1 is always simplify. What steps are entailed in simplifying? What's the first thing we usually do? Factor. And then what do we do if we can?
Cancel.
Factor, then cancel. Right? That's what we would have done yesterday. The only difference today is I have another rational expression over here. So I'm going to do the same thing. Yeah? Mm-hmm. Excellent. What is the second thing that we did yesterday after we'd simplified and factored everything?
Solve it, like put it in.
No, we did something special that we don't have to do normally.
Restriction.
Yes, we did our restrictions. Now, if you do the restrictions after canceling, you might get screwed over, right? Mm-hmm. So it's not really fair to call this 2. It's kind of 1A, isn't it? Because I should check for my restrictions right there before I cancel. Yeah? Okay. Then what? What would be next? So we've dealt with our rational expressions. So now we're going to deal with the equation parts of things, yeah?
Yeah.
Okay. So if I had this as an equation, x over 2 plus 3 over 4 equaled 9, what would be your next thing to do? It's factored, obviously. It's canceled, obviously. There's no restrictions, obviously.
Common factor.
Not common factor. We've already factored, but common something.
Common denominator.
Common denominator. Because it's a rational expression. So there's going to be denominators everywhere we need, yes? Now, in the canceling, that's going to take care of all the multiplying and dividing, isn't it? But any adding, check for lowest common denominator on what parts? Where do I check for common denominators? When I'm multiplying? Yes or no? When I'm dividing? When I'm adding? Yeah. When I'm subtracting? Yeah. So I check for LCD on all addition. Now, addition automatically includes subtraction, doesn't it? And now, over here, once I get my common denominator, then what do I got to do? To solve it, but I got to get rid of that common denominator, don't I? So I get my common denominator, and then step 4, I eliminate my common denominator. LCD by what? What gets rid of a denominator?
Multiplying.
By multiplying. Now, once my denominator is gone, I'm going to be left with something plus something equals something. So I can just do regular algebra, can't I?
Yeah.
Eliminate the LCD, and step 5, regular algebra. Because the denominators are gone. None of that is new math, is it? All right. So let's look at the first one. Step 1 is factor. Is there any factoring to be done there?
No.
No, so it's taken care of, right? Yes. Step 2, are there any restrictions? What is it?
0. X equals
X cannot equal 0. 3. Check for the LCD. What is it?
4x.
What's this guy's denominator? 1. So my common denominator, my LCD, the easiest way to check for it is to do denominator 1 times denominator 2 times denominator up to n, right? However many denominators I have. So what's my denominator? 4x. What does this guy need?
1 more x.
1 more x. What does this guy need?
4.
4. So what do I get up here?
X squared minus 4.
X
negative 2.
squared minus what?
28.
28. And all of that has to equal what?
3.
Why is it 12x? Because I got to check all my denominators. What's this guy missing?
All of it.
Both the 4 and the x over 4x. Now, I have all my denominators the same, don't I?
Yes.
So, watch. If I have x over 2 plus 3 over 4 equals, let's make that 8. What's my common denominator? 4. So this guy is going to become 2x, right? What's this guy going to become? 3, because he stays the same. What's this guy going to become? 8 times 4, which is 32. And all that is going to be over 8, correct? Or, sorry, 4. Right?
Yeah.
If everything is over 4, then don't I just get to get rid of it?
Yeah.
I do, don't I? Mm-hmm. Now, technically, what do I do here? Technically, I'm multiplying by 4, correct?
Yeah.
Once I multiply by 4, I have this 4 on the top and this 4 on the bottom. So what happens?
Delete.
Cancels out, and I'm left with just that. 2x plus 3 equals 32. So what is going to happen over here? How do I technically get rid of that 4x?
Multiply by 4x.
I multiply by the LCD, right? Once I have the LCD on the top and the bottom, what happens to it?
Just cancel.
It cancels out. And what am I left with? Step 5,
Squared.
regular algebra. X squared minus 28 equals 12x. Now that doesn't look like something we can solve. Or does it?
Yeah, we can.
What do I do with that 12?
I put it over there.
X squared minus 12x minus 28 equals what?
Equals 0.
0. What have we been doing all along when we see a trinomial? Factor it. X plus 2, x minus 14 equals 0. And we have seen this about 1,000 times, haven't we?
Mm-hmm.
So what are my answers? X equals what? 14 and negative 2. And I'm done.
X cannot equal 2?
No, x can't equal 0.
Oh, okay.
It can equal 14 or negative 2. Is everybody good? Nothing new, was there? Just a new application. So let's look at B. Is there any factoring to be done in B?
Yes.
Where?
2 z squared minus 4.
Z plus 2, Z minus 2, correct?
Mm-hmm.
Plus 10 over, is there any factoring to be done there?
Yes.
What?
6.
Bring out a 6 and I get Z plus 2 equals 1 over Z minus 2. Yeah?
Yeah.
Now what should I check for?
The common denominator.
No.
The restriction.
What is X not allowed to be?
Plus or minus 2.
Plus or minus 2. Now let's carry on. What is my common denominator? Z plus 2,
And 6.
Z minus 2, and 6, correct? Plus 2, minus 2, 6, plus 2, minus 2. Yeah? What does term A need? What's he missing?
6.
The 6. So what do I write here?
12.
12. What's term B missing? Damn it.
Minus 2.
What's term B missing?
Z minus 2.
Z minus 2. So what do I write there?
10Z minus 12.
10Z minus
20.
20 equals, what's this guy missing?
6 and Z plus 2.
But it's just a 1, right?
Yeah.
So it's 6Z minus 12. Or can I write 6Z minus 2? Is that okay?
I think it's a plus 2.
Yeah, it's plus 2. Is that okay?
Yes.
Does it matter which way I write it?
No.
Please notice I use both ways here. Does it matter? No. Now, is everything equaling the same denominator?
Yes.
So what do I get to do?
Cancel.
Cancel, cancel, cancel. And what do I get? 12 plus 10Z minus 20, because it's a plus there, equals, should I expand this?
No.
I'm trying to isolate Z. Should I expand this?
Yes.
6Z plus 12. Now what? What do you notice is the same on both sides? 12. So what do I get to do right away? Get rid of them. What's left?
6.
Where should that 6Z go?
And the other side.
On the other side, right? So what's going to happen? What's going to happen? What's going to happen with that 6 when I bring it over?
4Z
It's going to become what I'm going to get 4Z.
and 20.
Where should that 20 go?
Right side.
Right side. And what's going to happen to it?
20.
It's going to become
20.
20. What's the last step of regular algebra?
Divided by
What does Z equal?
5.
5. Now I just did a lot of work, right? Do I know I'm right?
Yeah. I mean, you can check.
How? I have what Z equals, don't I?
Putting the 5 in the Z.
What's 5 squared?
25.
Minus 4?
21.
2 over 21. What's 6 times 5?
30.
Plus 12?
42.
That's 10 over 42 equals
3 over 1. I mean, 1 over
1 over
3.
3, correct?
Yes.
My common denominator is 42, isn't it? So that would be 4 plus 10 equals 14 all over 42. Is 4 plus 10 14? So did we do it right?
Yes.
Yeah, sure we did. There's no way, no reason to wonder if we did it right, is there? Wonderful. Jazzcarn, you're doing the third one. Here's the pen. Or you're giving me your phone. Which is it? Perfect. Now you're going to pick up your pencil and you're going to write this stuff down. What do I do?
Factor
Where?
the other side, the left one. I mean, the right one.
I can only factor over here.
Yes.
So everybody start factoring. I don't want to walk you through this step by step. Everybody do their first step. Yeah, of course you do. Go. And who's going to tell me what to write? I would love to give someone the computer if they were willing. Too many hands, tough to choose. What am I going to write there? Is that one changing? No, it's not, because nothing can factor. Is the next one going to change?
No.
Why?
Because you can't factor.
Because nothing can factor. Is this side going to change?
Yes.
What's the numerator going to be? Minus 8? K minus 8 here?
Oh, no.
What's it going to be? Does it factor? No. So what's it going to be? Over what?
K plus 2 and K minus 2.
Have I factored everywhere I can?
Yes.
What do I check for now?
The restriction.
What are they?
K cannot equal to plus or minus 2.
Wonderful. Now what? What's
Common denominator.
what is my common denominator?
K plus 2 and K minus 2.
What does this guy need?
K minus 2.
K minus 2. What does this guy need?
K plus 2.
K plus 2. What does this guy need?
Nothing.
Nothing. So that's going to equal K squared minus 4K plus 24. Is that color visible on the screen behind me? It looks like crap on my page. That's visible? Okay. What is the green one going to be? What do I do with that? What do I do? Starts with a D. Ends with an E. Has double distribut in the middle of it.
Distribute.
Double distribution. Or how you know it, FOIL. What's 4K times K?
4K squared.
4K squared. What's 4K times negative 2?
8. Negative 8.
Negative 8K. What's negative 1 times K?
Negative K.
Negative K. What's 8K, negative 8K minus 1K?
Positive 2.
No.
What?
What's negative 8K minus 1K?
Oh.
Minus 9.
Minus 9K. And what's negative 1 times negative 2?
Plus 2.
Plus 2. Minus K1 times K plus 2. What's that? K squared plus 3K plus 2. Now what should I do with that denominator now that everything's over the same thing? It's gone. So what do I do now with all these numbers? If I was in the 9th grade, not the 11th grade, what would you do with all those K squareds, all those Ks, and all those constants? I'd collect like terms. What's 4K minus 1K? 3K squared. K squareds are gone. What's negative 9K minus 3K? Negative 12K. K's are gone. What's 2 minus 2? 0 equals K squared minus 4K plus 24. Now what would you do if you were in grade 9? Are there more like terms to collect? I see some. What are they? Get those K squareds together, which means something's got to move. Does it make more sense to move positive 3 things, or does it make more sense to move positive 1 thing? When you move out of your house to go to university or just move out of your house, would you rather carry 3 things or 1 thing? 1 thing. So you bring 1 thing over here. What happens to it? It becomes negative, so I get 2K squared. So I'm moving everything to the left, so I better bring this 4. What happens to it? Plus 4K. Negative 12 plus 4 is negative 8K. What happens to that 24? minus 24, because it moves over, equals 0. If I was in the 10th grade, what would I do with that first?
Divided by 2.
I'd simplify by GCF, yes? 2, k squared minus 4k minus 12. Then what?
Factor.
Factor again. Where?
K minus 6.
That. And what will I get?
K minus 6 and K plus 2.
K minus 6 and k plus 2 equals 0. How do I solve that?
K minus 6, K minus 2.
K minus 6 can equal 0, or k plus 2 can equal 0. So k can equal 6, or k can equal negative 2. Which one of those is the right answer? Which one of those is the right answer? Why?
Because it's negative.
K cannot be negative 2. So k equals 6. All right? Anything new? No. Factor and algebra. How long have we been practicing algebra? Since kindergarten. The very first lesson in math was an algebra lesson. Your teacher just didn't call it that. How long have we been practicing factoring? Since the third unit of grade 10. Are we all past the third unit of grade 10? Yes. Some of you have been doing factoring since grade 6. Turn the page over. Start working. Page 137.
Is this homework?
Yeah, sure, you betcha. Except class is over.
Yeah.
So,
137 is the homework.
137 is homework. Yo. I need to get the marks from your quiz
And the assignment.
and the assignment. I guess I'm getting them Monday because the bell's going to ring in 3 minutes. 2 minutes. Or if it was the first block, it's going to ring 15 minutes early.
Oh, yeah.